Throughout Unit 1, this week, Week 1, and next week, Week 2, you will be learning some foundational principles that relate to the more technical aspects of system safety and hazard analysis. And these foundational principles, we will build upon them and use them extensively in future weeks as we get into the more technical aspects of hazard analysis. As such, it is important that you understand fully these foundational concepts at the outset so you have them mastered when we get into hazard analysis techniques. The first principle that we may appear to belabor here in Week 1 is the definition of the system. Set system boundaries. Hazard analysis on a system, depending upon the technique, can get very cumbersome and complex. As such, it is imperative to first define the boundaries of the system that will be analyzed. The United States Air Force System Safety Handbook, from your reading assignments this week, states that the system is a relative term. Systems comprise of subsystems, but the subsystem in and of itself could be considered its own system with subsystems below it. The example that we give in the PowerPoint is that of a pneumatic system on a Boeing 737. And depending upon your engineering perspective, you may consider the actual aircraft, the whole Boeing 737 itself, a system, with the pneumatic system as just a subsystem of the actual aircraft. However, if your analysis requires, you may consider the pneumatic system itself to be the system to be analyzed, limiting your analysis to that, with subsystems under it. If your responsibility lies with ground support equipment, the ground cart itself, which is also a subsystem within the pneumatic system, the ground cart itself may in fact be your system to be analyzed with subsystems underneath it. Whatever the case, your system needs to be precisely defined and limited. That's the crucial part. It must be limited in order to ensure the system safety objectives are met without allowing the safety analysis to get overly cumbersome.